Hello and welcome everyone to the C++ 101 class. This is Friday, April the 20th, I do believe, and I'd like to welcome you guys all in. Your lead instructor for this 8-week class will be Mr. Nelson Lakay. Our TA will be Mr. Gavin Whitlock, and I will be joining into this class as well. Basically, I'll be around to provide any extra assistance as need be. So we had the first class already. That was this past week, and it was open to everyone. But starting tonight, this is now a member-sponsor only exclusive class. With that, everyone that is not in BuzzNet, you need to get into BuzzNet. People that are not in BuzzNet will end up being removed from the webinar system, so this is extremely important. All you need to do is open up a browser and point the browser over to buzznet.3dbuzz.com. We're no longer doing the IRC thing. That was only because it was an open class, not a member-sponsor class. Now that it's a member-sponsor class, you must be in BuzzNet. So if you do not want to be removed, please make sure that you get over into BuzzNet. This is extremely important. All right, anything else, Nelson, that you can think of?
No.
So just jump right into this. Let's get things rolling. Okay, good enough. Well, let's just jump right in then.
Okay. Well, let's talk today about code.
Now, while you're getting that kicked off, I do want to say this real fast, and that is that while we are dealing with different IDEs from different operating systems, we will be doing all of our coding on a Windows platform in Visual Studio, so you can follow along in your IDE, but I'm just letting you guys know we're not going to be jumping over to each IDE and doing the exact same code over and over.
Okay. So let's talk about something. Let's quickly recap a little bit about integers. And I do like asking this in some of the classes, at the beginning of some of the classes, and that is how many people here are completely new to programming, not just new to C++, but completely new to programming. I'd like to know who here is, yeah, Gavin. Alrighty, so we have a good amount. Okay, so basically what we have in C++, the first thing I'm going to talk about is a way to, basically we're going to talk about arrays and what we can do with arrays in relation to, well, variables. So just to recap really quickly what we learned last week about variables, a variable is a named location in memory, and that named location in memory has a type, and this type is understood by the compiler. The compiler knows what an integer is. When this function begins to execute, the compiler asks the operating system, or generates the code that asks the operating system, to allocate enough memory for us in order to store the data that we've requested for this particular function. So the amount of memory that the compiler is going to ask the operating system for is determined by the type of the variable. Type of the variable always precedes the identifier of the variable, which we use to identify that named location in memory. So again, an integer type, or an int type, is typically 4 bytes wide, meaning it consumes 4 bytes of memory. And what? Oh, never mind. I got distracted by repeated.
Do not look over at BuzzNet. And questions must go in the questions panel if you want us to answer them, because that's exactly what happens to Nelson. He gets confused.
Okay, so we have a variable. It has a type. It has a name. And this type determines how much memory is allocated. It also determines what the valid values that can be stored using this identifier, using the identified location of memory. So if you recall, an integer type is any positive or negative whole number. And of course, there are upper and lower bounds for what an integer can store. As an integer couldn't store every single whole positive or negative whole number. But in general, it's useful to think of an integer like positive or negative whole numbers. So basic variables are really useful and important and allow us to do interesting computations. For example, I can write a simple program here that asks the user for their age. What am I doing? And perform some sort of computation based off of what they typed in. So we could say if age is greater than 10, we can execute some bit of logic. So that's really one of the main things that we do in programming. We accept input from the user, and we output some sort of result of some sort of computation based off that input. So individual variables are good, and they are very straightforward to use. But a variety of problems that you might want to solve in programming require that you be able to dynamically access individual items or individual variables, not by name, but by index. Now, a lot of people will do something like this. Let's say we wanted to store the price of 4 products. We could say double product price 1, 2, 3, and 4. That would be a very common way to solve this problem if we didn't have the concept of arrays, which I'm about to get into. The way we would write a program here that would allow the user to enter prices for each one of these products, and then maybe the program will tell us which one is the most expensive product. We could write it like this. We could say enter price for product 1. And we can say cin product price 1. And we can copy and paste this code over and over and over again 4 times, update the variable name, and as of right now, as of line 23, we have 4 variables that contain prices for 4 discrete products. So if we wanted to find out which one of these was the most expensive, we could do something like this. We could say double max price equals product price number 1, and then we can say if product price number 2 is greater than max price, then we can say max price equals product price 2, and then we can continue this over and over again for product price 3 and product price 4. And then we can say at the end of the program, cout the most expensive product costs max price. So now if I were to run this program, I could put in, actually I need to go ahead and halt execution. I can put in 1, 2, 3, 4, and I'll get the most expensive product costs 4. And we can put a nice little $sign right there and make it look a little nicer. Okay, so if I were solving this problem, if I wanted to find the most expensive or the price of the most expensive product based off or of 4 products of the user's choosing, I could represent that logic with this. Does everybody, and I'm especially talking to people who are absolutely new to programming, understand the logic of this program at least? Because I am going to be playing with it a little bit and showing you guys how we can make this a little bit more succinct by using a feature of the C++ programming language.
Any particular feature?
Well, arrays. But we did have a not really. Double, are there any questions that you have about this program? All right, well, if you have any questions, put them in the questions panel. Okay, could I explain what double means one more time? Yeah, a double is a data type. So like I said before in the brief recap about variables, every variable has a type. The reason it has to have a type is that the data inside of a variable, the way it behaves and the way it interacts with everything else in the program is very important. And different kinds of data interact with the program in different ways. So we need to annotate our variables, or not only ask for memory, but we also need to inform the compiler what stuff we are doing with this memory. Otherwise, the compiler wouldn't know what sort of instructions to tell the computer to operate on this memory. So the double type is, unlike an integer, which can store positive or negative whole numbers, a double type can store positive or negative floating point numbers. And a floating point number, if you think about that in terms of English, you think about a little dot that's floating around a number. And that's commonly referred to as a decimal point. So any number that has a decimal point is referred to as a floating point number. The float is a data type that allows us to store positive or negative floating point numbers. The double is a data type that also allows us to store positive or negative floating point numbers, but it allocates twice as much memory for us, thus giving us twice as much precision. And precision is the amount of significant digits that a number can contain, basically. So the double type allows us to store decimal numbers, or floating point positive or negative numbers, and it relates to the float in that it has double the amount of precision. So does that answer your guys' question, Thomas and Robert? Okay. Is there such things as underscore underscore in64 and underscore underscore in 128 on 32-bit compilers? I'm not aware of those types and if they are valid on particular compilers. I tend to avoid the more esoteric data types in the C++ language. There are types that allow you to store infinite amount of precision. Well, not infinite, but conceptually infinite, by allocating more memory as they need to. And generally, I would prefer using those than shoehorning some compiler-specific data type into my program on possibly an architecture that doesn't support it. What situations that come up often in programming is that used in? Well, doubles and floats are very commonly, well, they have to be used for anything that you need a floating point number for. So think about money. Money in every culture I'm aware of is represented in dollars and cents. Well, actually not every, but still. And when I say dollars and cents, I mean a big number on the left of the decimal point and smaller fractional units is what I'm saying. A lot of cultures have fractional units in their currency. And so as a result, in order to store that information properly, we need a floating point number. We need a number to store those fractional units. What does the sin.ignore function do again, if it doesn't disrupt the lesson too much? Yeah, we got a few questions in the Monday class about it too. But what it does is when we use cin to get a number and we hit the enter key, the enter key is actually represented as a new line character, or a carriage return in a new line character. And those characters, or that character, I can't remember which one, or if the sin object eats the carriage return or not, but it leaves some sort of return, some sort of new line character inside the internal buffer. And what happens is the sin.ignore function removes those items from the buffer. If we did not do sin.ignore, when we went to line 41 and did sin.get, the result would be sin.get would immediately return with the last character that was in the buffer. But obviously we don't want that, because we want the program to halt execution until the user hits enter, at least here on Windows. If you're using an IDE with a terminal that's built in, this isn't something that's required. But for debugging and development, it's a very common pattern to keep the window open so that you can view the output. What do you think about Anthony's question, Jason?
Didn't you cover all that last week?
I can't remember how in depth I got into it last week. Sin.ignore, what it does is it clears everything that's in the sin buffer. What happens here is when sin is asked to retrieve a double value, such as product price 4, it's going to sit there, and when the user types in a number and hits enter, it'll yank all the digits out of the buffer, but it's not going to yank the new line out of the buffer, meaning the sin buffer has data in it when after the input was gathered from the user. But that's problematic because we're using sin.get in order to pause our program. Now, if you execute sin.get and there's something still in the sin buffer, then it's going to execute and return immediately. And as a result, it will not hold our console window open, which is the behavior that we're expecting. So after sin product price 3, what happens to the new line when you do sin.product price 4? That would be still ignored by trying to get a double. There's no reason for it to grab that data. Does sin behavior, clearing the buffer, have any practical use or could be considered as a bug? I'm sure it has practical use. At some point, someone decided to make the behavior like this. I'm just not aware of that. Frankly, it feels like a bug to me. It feels stupid. But then again, I'm not the one who invented C++, so I can't say any reason why they would make that behave like that. And it is too late now because C++ can't change in any major way, not like that, now that it's been around for so long. Okay. Well, I guess all right, Gavin, time me.
Time me
for 4 minutes.
Okay, go.
Okay, so the difference between C, C++, and C#, they're all similar in their syntax, but they differ. Specifically, C and C++ differ from C# in how they're executed. C and C++ are native languages. They're very old. Well, they're actually relatively old compared to C#, and they've been around for a long time. They're native. They execute directly on your CPU. They're very low level. Now, C is older than C++, obviously, and it doesn't have as many features as C++ does. C++ adds features such as object-oriented programming to the language itself. So it allows us to express our problems in a more concise way than C. C was a very minimalistic programming language that didn't have a whole lot of features in it. C++ adds quite a few features to that original specification. Now, C is backwards compatible with C, so it's quite often that you'll see people using C code inside of C++, which is perfectly valid. C#, however, was created by Microsoft in the early 2000s. It is a managed language that runs on top of a program called the CLR that manages your application as it runs and provides many additional features that are not possible in C++ because it's runtime. Then again, the runtime does introduce some overhead, which is the most common reason why people will choose C++ over C# when working in a purely Windows environment. As far as which one is better, that's up to you. That's up to what your problem is. There's many different uses for the variety of programming languages that exist. And C# is similar. C#1 was similar to Java today. But since C#1, it has surpassed Java in the features that it supports and has pretty much taken off as its own language and the very, very interesting language that combines functional, dynamic, and imperative and object-oriented programming together.
You've got a minute and a half left on your 4 minutes. Streeter, that was 2.5 minutes. Surely you can wait 2.5 minutes just to caption people up.
I want to point out, though, that C# isn't necessarily slower than C. Now, it can be. And C# lets you do things that can lead to people being ignorant of how their code is interacting with the computer. That being said, poorly written or well-written C# code will always outperform poorly written C++ code. Just hands down, that's how code works. But the thing is you shouldn't. It's not that useful to think of a C++ as significantly faster than C#, because if you need performance in C#, there are options available to you. It's just typically a person with performance in mind when creating an application will typically choose C++ over C#, and a person not so concerned about performance but still performance aware might choose C#. If you learn C++, you should have a much easier time learning C#. Yes, you will. Is there much future for C++? Definitely. C++ is not going away anytime soon. There's too much existing code written in C++, and there are a lot of new projects being written in C++. But neither is C#. And neither is C. C is still commonly used for driver development, for example.
Cool.
Okay. So that was that. I don't want to spend a lot of time talking about other languages in any of the specific courses. We do have a C# course if people are interested in that. But that is a valid question, I think. So, yeah, there's the answer.
Show us arrays, dude.
Yes. Okay, so everybody is pretty comfortable with this code, correct? Because I'm about to change the code and actually show people how we can make this code a lot more robust. Now, the problem with this code is repetition. There's so much repetition in this code. We have repetition right here. We have repetition right here. We have repetition right here. There are 3 instances of code repetition that doesn't need to exist. And these sorts of problems are so frequent in programming that most languages, almost all languages to my knowledge, support the concept of an array. Now, let's think about how a person would go about refactoring this code so that it was a little bit more robust. The first thing a person might do is start off, okay, wait a sec. I notice a pattern here. There's a number right here and a number right here, and they're both incremented. This sure looks like a loop. So let's try a loop. Or wait a sec. We haven't talked about loops yet. Let's talk about loops and arrays at the same time, because honestly, they're both go pretty much hand in hand. So the first problem with this code is the repetition. And a way that we solve the repetition in programming is with looping. And looping looks, at least the first loop we're going to introduce, it looks a whole lot like if statements. It's basically the while keyword followed by a parenthesis, followed by another parenthesis, followed by a block. And inside of this parenthesis goes a Boolean expression. Now, the cool thing about a loop is that a loop will continuously execute, at least the while loop will, until the expression inside of the parentheses are false. So, for example, I could say int index equals 0, and I can say while index is smaller than 10, index plus plus, cout I index. Now, what this code is doing is we're first establishing 4 bytes of memory here and setting those bytes of memory to 0 and naming it index. Then we're entering a while loop. We're saying while index is smaller than 10, continuously execute this block of code. The block of code says, go ahead and print out index, and then do this thing right here. This is called incrementing. Basically, what this code is it's perfectly equivalent to if I had said index equals index plus 1. The increment, the postfix increment operator, basically takes the variable that we have and adds 1 to it and actually mutates the value. So it is a fairly nice little shorthand for doing something that's very common in programming.
You can do the opposite as well, of course.
Yes, you can do a decrement as well. So I want to point out that something that's really important about loops, if this is the first time you've seen a while loop, this condition inside of here will only cause the loop to stop when it evaluates to false. Which means that logically, if inside of our loop we do nothing to alter the values that are used in this expression, we have entered what's called an infinite loop. So first I'll go ahead and demonstrate what happens when we run this code. You'll see that we get I is 0, I is 1, 2, 3, 4, 5, 6, 7, 8, 9. What's going on here is that we are, again, setting our index to 0, entering a while loop and saying, while index is smaller than 10, continuously execute this code. First thing that's going to happen is that we are going to print out the value of index, which is going to be 0 on the first iteration. Immediately afterwards, we increment index, and then we jump to the end of the loop, which causes execution to go all the way back up into this condition. When it's inside of this condition, it will evaluate this expression again. It'll say, is index smaller than 10? And because index at this point is 1, 1 is smaller than 10, then the loop continues, and so on and so on. We can actually represent this in the debugger where you can see execution jumping. And if we pin up index, you'll notice that the value of index increases as we continue this loop. But watch what happens when we hit 10. So now that we hit 10, index is now equal to 10. Execution is now in this expression. When I hit F11, what's going to happen is execution jumps all the way to the next executable line of code, because now index is no longer smaller than 10. 10 is not smaller than 10. Therefore, the while loop terminates, and we continue execution normally.
It's a good question at this point in the question panel. Are while loops executed at least once?
No. While loops are not executed at least once. If I were to set index to 10 and hit F5, you'll notice that the while loop doesn't execute at all. I don't want to talk about this too much, but we can have a while loop executed at least once by specifying do in front of it and putting the while loop at the end, or the while statement at the end. But we're not talking about do whiles. Just talking about whiles because they are the simplest form of looping. Okay, is using while loop to always execute until the code can get to a return statement within an if statement within a loop? What? Using a while loop to always execute until without having some way to exit the loop any other way. Oh, he's saying entering an infinite loop and then using a return statement to exit the program?
I think so.
Yeah, I'll talk about that in a second. I did get a good question. How did I use the debugger to go step by step? Well, I set a breakpoint right here by clicking on the gutter. I hit F5, and then I continuously hit F10 or F11. Actually, that's not a good example because I have the variable as 10. You can continuously hit F11 or F10. Actually, if you hit F11 too many times, you'll get into cout, which you don't want to see. You really don't want to look at this code. So continuously hitting F10 will loop over. Okay. To answer your question, though, using an infinite loop, actually, I'm going to talk about infinite loops in a second, so hold on, Robert. How did I pin the variable? All you have to do in Visual Studio 2010 is you have to hover over it and hit this little pin icon. It's a very handy little feature. Do certain loops take up different amounts of bits in memory? Loops don't take up any storage or any storage at all in memory. Now, again, though, loops do add instructions. They do add CPU instructions that have to be executed. And certain loops will add certain or more or less or more or fewer instructions to the generated machine code. But they do not take up any more memory by themselves. Now, that doesn't mean that you can't allocate memory even inside the expression if you wanted to, although that'd be silly, but you could. It's not going to take up more memory by itself, although you can get loops to take up memory if you program it like that.
Cool. So how does this help us with our product prices then?
Yeah, actually, first, somebody asked about infinite loops.
I thought you... Yeah, okay.
Well, the infinite loop is basically if I have a loop here that doesn't alter any value that's used in the expression, logically, the loop will never terminate. So by commenting out this index incrementation, is that even a word? I've never used it before. If I comment out this line of code and hit F5, you'll notice that we enter in what's called an infinite loop. And the infinite loop, not surprisingly, never exits. Now, somebody asked if it's good programming practice to intentionally have an infinite loop and then ask the user, like let's say we have, do you want to quit 1 or 0? And then we can say int choice, sin choice, if choice is 1, then return 0. This kind of code is fine. There's really no problem with it. So we can continuously type in any value we want until we type in 1, and then our program returns. There's nothing really, this isn't bad programming practice. There are uses for infinite loops.
The key point being you do, at some point, give them a way to get out.
Yeah. Isn't a game loop an infinite loop? Depends on the implementation. I mean, oftentimes they are, but I could just as easily say, I don't know, while is playing. And then is playing could be a Boolean. That's set to false. This isn't technically an infinite loop, I guess you could say, because it's not a constant inside of the expression. And then we can simply set is playing to true if we wanted to quit the program or end the loop. Okay. Doesn't Windows API force infinite loop?
I think.
I'm not familiar with what you're... Well, I am familiar with the Windows API and DirectX API, but I don't really know what the... I mean, there are...
Getting a bit sidetracked into...
Yeah, a bit. But it's kind of a terminology thing. I'll just leave it at that. It's a terminology thing. The Windows message loop is not an infinite loop because it has an exit condition, generally speaking. And that exit condition is receiving a message that tells the program to exit. So technically it isn't an infinite loop. An infinite loop, at least as far as my understanding of the terminology, is in the loop with a true as the expression. This is an infinite loop, this is an infinite loop, this is an infinite loop, and is legal C++ for some reason, and so on and so on. So while loops continue forever until the expression is false. Yep, that's what they do. Okay, so arrays. Let's talk about how we can make this code better. Now that we've talked a little bit about looping, we can see that we can identify many parts of this program that could benefit from looping, just right off the bat. And we can do so because the code is completely identical for every product price. Can while loops be nested? Yes, you may nest as many while loops, for loops, do while loops, if statements, switch statements as you possibly want. There are no rules as far as nesting many or almost all of the C++ constructs as far as looping and conditionals go. Okay, so let's try to make this into a loop. So let's go ahead, and this is the most common solution a person will come up with having just learned about while loops. They'll say int product number equals 1, and we'll say while product number is smaller or equal to 4, we'll say this, and then we'll say product number plus plus, and then we'll be like, oh, sweet, so now we can delete all this code. Awesome. And then we'll be like, okay, so now how do we fix this code to work properly? Well, we'll start off with this. Oh, that's easy enough. We can simply, instead of printing out a constant, we can print out a variable. Very straightforward stuff. However, we have a problem. In C++, you cannot dynamically refer to variables. There's no way to choose which variable you want to use at runtime. That's not true for all languages, but it's true for C++. I cannot say, I've seen some people try to do something like this, like product price plus product number. What this expression means is the variable product price added to the variable product number. And of course, since product price doesn't exist, we get an error. So how do we access product price variables 1 through 4? Well, like I just said, you can't. There's no way to. But the C++ language gives us a feature we can use to actually perform this operation that we want to. And that feature is called an array. And an array is a collection of items. Now, that in itself isn't very interesting. So look at this. If I go double product price is 4, I've just declared an array. I've declared an array. You know it's an array because it looks like a variable. It has a type and it has an identifier. But it has these square brackets followed by a constant number followed by square brackets followed by a semi. This is a 4-item long array of double values. This code and this code is functionally equivalent as far as the CPU is concerned. As far as the CPU is concerned, we are allocating 4 doubles.
So you have to allocate it. You can't just have open and closing square braces.
No, this does actually get allocated on the stack in C++. So these are actually, this is an allocated but uninitialized array of variables. Someone distracted me in the BuzzNet. Something about a file.
Stop looking at BuzzNet. Close BuzzNet. Yeah.
Okay.
You can't. What happens if I don't know how many product prices I want to put in? I have to know in advance. Yes?
Oh, yes. Well, no, I'm just saying I thought you meant that you had to instantiate the array like you did in C#, which you don't.
No, I was asking a leading question.
Oh,
about the number of, have.
So, and that's very important. And again, remember that this is functionally equivalent to this, meaning this on the stack allocates 4 doubles, just like this on the stack allocates 4 doubles. Allocates the exact same amount of memory, but here's the important thing. You cannot decide to allocate more or less data of an array at runtime, because at compile time, the compiler has to know how much data to allow main to use when main starts. Otherwise, main's not going to have enough storage available to store all the data that it needs to store to perform its operations. And if it doesn't have that, then how does it even get to the point where it can decide whether or not to, how many items to store in this array? Now, there is such a thing as dynamic memory allocation, but we're going to be waiting until our discussion on pointers before going into that. So for right now, you can only create an array of a constant number of items, and this array cannot change in that you cannot add or remove items from this array. Because this memory is made available to us the moment the main function is entered and the main stack frame is pushed onto the stack, after that's done, there's no way to make this variable have any more or fewer items. Okay, so if this and this are the exact same, if this and this are the exact same, why would you choose to use an array over an equally amount of initialized variables or declared variables? And the answer is, with an array, you can, at runtime, decide what item you want to access inside of it, which gives us the functionality we were previously lacking and allows us to complete the refactoring on line 9 through 15. Because now we can say, okay, we want product prices. We want to print into product prices, but we want to do so at index product number -1. So might not be immediately obvious why I had to do that -1 right there. I'm going to rewrite the rest of the program, and not rewrite, but I'm going to modify these errored lines out to show what it would look like without a loop, but still using an array. Okay, do have some questions. Okay, so bring in your questions about arrays. Actually, first, before I do answer those questions, I am going to talk a little bit about indexing. Now, indexing an array starts at 0 and ends at the amount of items in the array -1. So you'll notice the range of indices we can use to index this array starts at 0 and ends at 3. When I say index an array, what I mean by that is we're yanking a value out given a particular address. We're saying, okay, I want your value at address 2. Now, address 2 is the third address, so as a result, you get the third item. Address 3 is the fourth item, and so on. So C++ arrays and C arrays and C# arrays and Java arrays and JavaScript arrays and PHP arrays and Ruby arrays and pretty much every array that I've heard of, minus a few exceptions, are all 0-based. So that's something very important to realize, especially if you're coming from a language like a BASIC or Cold Fusion, which use one index-based arrays, which drive me insane. But this is just a very important thing to stress if you are coming from a different language. And if you're not, it still might not seem immediately obvious why we start at the why we start at 0 as our first index. And one of the ways to think about it is, think about it like this. Think about the number in brackets is how many items you want to go forward to point to the item that you want to select. Now, product prices always points to the first item. So the first index is going to be 0 because we have to move 0 items forward to see that item that we're pointing to. 1 is the second index because if we step forward once, we are now, instead of pointing at the first item, we're pointing at the second item. 2 and 3, same sort of thing. Okay. Let me see. Should we initialize our arrays to 0 when we define it? That's a good question. The answer is generally going to be yes. But I didn't do it here. And the reason I didn't do that here is because I am initializing all of these arrays, all of the array values right here. I'm immediately going from declaring the existence of an array to stuffing it with data.
So if the point was down the line where you actually put the data in, would you presumably would you make variables? Would you initialize all the oh dear, I've lost the ability to speak.
Actually, it depends on the situation, and the reason is that using an uninitialized array variable will actually throw a runtime exception in Visual Studio, which is what I want, because I don't want my program ever to be accessing an uninitialized array value. But there are a lot of cases where I'll create an array, but I'll only stuff it with, let's say, 5 items. Let's say it's a 10-item long array, and I only stuff it with 5 items. In that instance, then I will initialize everything to 0. Because the point is if you expect that the array could, or if it's acceptable to think that your array should be in an initialized state, and you are unable to initialize everything within that array to a very specific value, then you should initialize everything to 0.
Gotcha. Chris just mentioned something in BuzzNet that I think is key, related to what Bando posted directly above it.
No, it shouldn't.
Yeah, that's why I brought it up.
Yeah. Somebody said that this should be smaller or equal to 3, and it shouldn't be. And the reason it shouldn't be, it comes back to how this code is working. This code starts with a product number of 1. The reason I decided to have it start with a product number of 1 is because the first goal of this loop was to print something to the user. And I didn't want the user interface to say enter price for product 0. I wanted it to say enter price for product 1. So as a result, I made this variable 1 index based. Because I made this variable 1 index based and I wanted it to loop 4 times, instead of using the less than symbol, I have to use the less than and greater than operator. But when I go to reference a value inside of the array, I subtract 1 from it, thus turning the 1-based index into a 0-based index, which is what arrays expect.
Would you normally do it that way round, or would you logically flip it? Would you add 1 in the line 11?
I normally would have it flipped. It was just the reason that came out like this is because the first problem I was trying to solve was this.
Yeah.
And then the second problem was this. But normally, if I was writing it, I would have this product number be index based or 0 index based. But the point is that both is equally valid.
Yeah. I was just thinking in terms of best practices.
Yeah, I would generally have my counters always be 0 index based because it.
Well, go ahead, change it up.
Well, yeah. So I do basically this, and then I would remove the -1 and add a +1.
Cool.
Okay. Are there arrays in C++ that resemble array list like in Java that allow you to add or remove items in the array? Well, here's the thing. There is, but they're not called arrays. An array, in fact, they're not even called arrays in Java either. Arrays in C++, C even, C#, and Java are this, where the items cannot change. Now, of course, in C++, C#, and Java, there are special objects that allow you to mimic the behavior of an array that can contain X amount of items. In C++, that is called the vector. The corresponding class in C# would be a list. The corresponding class in Java would be the array list. But in all those languages, arrays are immutable. They cannot change how many items they contain during execution. But there are ways to have that functionality. That being said, using that functionality in C++ requires some additional considerations that you wouldn't have in other languages. So as a result, we're not going to be covering vectors quite yet, but we will be covering vectors. And again, the vector is a type that allows us to store 0 to many items in it.
But we'll get to that when we get to...
Yeah. Okay, do you consider it to be more readable to just set the product number to 0 and not bother with the product? Yes, I actually do consider this to be more readable. And I will often do this. I guess probably might have what threw me off was I wasn't using a for loop here. I don't know.
Yeah. When the array is stored in memory, does it store the literal indices to match the value of the elements in the array, or just use the reference indices to do the stepping forward like you mentioned?
Let me see. Array store memory, does it store the literal index? Oh, no, it does not store the literal index. In memory, well, here, I can just draw it out for you guys if you want.
It basically does how you described the indexing, doesn't it?
Yeah.
Doesn't it? Yeah.
So, for example, if I have a double stuff array that has 4 items in it, what happens in memory is we get a double value.
A double.
A double. Dobby.
You can do it.
Hey, it's Jason.
Hey.
Hooray.
Oh, you just came to see me fail at this? Make fun of my penmanship?
Oh, we sent out worldwide messages to everything. You know, there's an RSS feed. Nelson's getting on Photoshop. Quick, everyone.
This is how it's stored, how an array is stored in memory. What's going on here is this double stuff are 4 doubles that are stacked contiguously in memory. Now, the double stuff array itself conceptually literally points to the first item inside this list, or inside this array. This is very important. And this is something that we are going to be talking about a lot in the C++ course, particularly because I know that a lot of people here are very interested in how their programs interact with memory. But an array does not allocate any memory above or below the data it stores. It literally only stores the data that it needs to fill however many items that it needs to fill. So right here, again, there's nothing, yeah, there's just nothing. This is just a naked list of doubles that we can loop over. And here's the great thing. Right here is memory as well. When we ask for stuff, let's say at the 10th index, guess what happens? We actually access undefined memory. So if we ask for item 10, that means we are asking for 7 times 4 bytes past the end of this array. Or not 7 times 4, 6 times 4. So we're going 24 bytes in the future.
The short version is, for goodness sake, don't do this.
Will it let you do that? Right? Stuff 10, that is. Yes, C++ will let you do this, and you will access random bits of memory. And this is called a buffer overrun. And this is not only one of the most common reasons why native programs crash, but also one of the most common forms of vulnerability inside of a program. Because it allows a person, potentially a malicious person, to use a program that has a known buffer overrun in it to write to an arbitrary location of memory inside of that program's process. So I just want to point that out. That is what a buffer overrun is. This is how arrays work. This is how they're laid out in memory. So when I access stuff at 0, I get the first double, stuff at 1, second, stuff at 3, or stuff at 2, third, stuff at 4, or words and numbers. You know what I'm saying?
Yeah. So assuming that you'd initialized that double, if you then said auto d equals stuff sub 2, how does it approach that?
You mean if I did auto blah equals product prices at 2?
Yeah.
Statically at compile time. And in fact, I could do this, and it would be the same. It just knows that because this is a double array, accessing it via the index is going to return a double data type, which is going to result in this expression being a double, which is going to result in blend.
Sorry. Yeah, no, I wasn't so much asking about the auto part. It was the, how does it actually get at that information in order to assign it on the whiteboard?
Oh, right. Yeah, so, yeah, if you access stuff at 2, just to give a more visual explanation, what we'll do is we'll start at stuff, and stuff starts right there on that first double. And then we'll move 1, 2 into the future, or not into the future, we'll move that far forward, and we'll access the third double. But what data type? Oh, are you asking? Sorry. BuzzNet confused me again. Okay. So is everybody good with how doubles are laid out, or how arrays are laid out in memory?
And make sure to look through the questions panel, too.
Yeah, I'm about to do that.
Okay.
Because I was actually answering a question from there, but some more popped up while I was...
Yeah.
Okay. Can you initialize the values array to 0 at once? I believe there is a bit of syntax to do that for us, where we will simply say equals 0, and the C# or the C++ compiler does have, yeah, it will extrapolate that value between all the indices in the array. So that's how we could perform that all at once. That initialization all at once. Okay. Do you need the parens around product name 1 on line 11? I don't think so. Pretty sure you don't. Yeah, it should work fine. But I am generally hesitant to do that because parentheses add a little bit of language to the person reading your code and makes things a lot easier to read when you have an expression inside of another expression.
Can you have an array of arrays?
You can have an array of arrays. But I don't want to get too far into... yeah.
And make sure to, continue going down through the questions panel.
Okay. How do you initialize all array elements to 0? Well, I answered that. Can you have a user input the amount of indices for the array during runtime and have the array created that way? For example, ask the user how many product prices they need and create an array with that variable. You can and can't. You can't with this way that we're using arrays right now. You can with dynamic memory allocation. We haven't talked about dynamic memory allocation, and we are not really going to until later in the class or later into the course, because it does bring up a whole lot of interesting problems and ideas that people are going to have to learn. Right now, because we are not using dynamic memory allocation, that means that we cannot decide ourselves. Or we can decide ourselves, but we cannot let the user decide themselves how much memory our program will allocate. And because we cannot have the user decide that, there's no way for us to initialize any more data or declare any more data than what our program already asks for by default. So with this syntax, without using instantiation or dynamic memory allocation, there's no way for us to, at runtime, determine how many values should be in this array. Why wouldn't creating the array without any assignment allocate the memory simply based off the type of array we created? Wouldn't creating the array without...
Well, I think what he means is, why doesn't it assign to 0 automatically? It knows it's a double. It knows how big a double is when you create it. Why does it have to then assign to 0?
Because it doesn't. It just doesn't. I mean, ask the C++ guys. Obviously, if we were to do that, if the C++ developers or creators were to have that behavior in the language, it would result in a bit of an overhead, because it would take time and CPU horsepower to set all that memory to 0 and clear it out. However, it is very common in a lot of other languages that things are initialized to default values. But in C and C++, they're not. It just doesn't. C++ is laid back. It doesn't assume or judge. Yeah, pretty much, and it's very liberal when it comes to data types too. But we are taking the time to set it to 0 manually. If you are. Remember how I said before, the only time that I will initialize all the values of an array to 0 is under one circumstance. And that circumstance is, I am going to fill the array partially with data. And then, after I fill it partially with data, I expect every element within that array to be valid. Otherwise, I would not initialize everything to 0 in an array. Because if I did not, at a point in code, know that the array should contain valid data, and I accidentally accessed data inside of the array that wasn't valid, that would indicate to me an exception would be thrown in the Visual C++ debugger, and it would tell me that I have a bug in my code. I didn't understand my code well enough to realize that the array wasn't initialized before. So I would want that to be caught. However, if, for example, I create an array of 50 items and I only fill it with 30 items, let's say I'm reading from a text file, and there's only 30 items in the text file, then I'll initialize the rest of them to 0, because at that point, conceptually, the array should be in a valid state. Okay. Why wouldn't create does everything in between stay undefined, uninitialized? Everything in between. Are you referring to this? Because the answer is no. This memory right here that we're essentially jumping over could be valid code. I mean, it could be the next program over. It could be the next another thread on another call stack. It could be very unlikely, but it could be a device driver that's loaded into memory. It could be another local variable that's initialized near our array. Or it could be just garbage, unallocated garbage. Okay, when defining an array, are its elements allocated in memory one after another? No. Allocating an array. Now, I want to point out this, though. When I say we're allocating an array right here, we're kind of not. We're doing so in a very roundabout way. What we're doing at a low level is we're telling main, the function main, that when the stack frame for main, or when the data that main's going to be using is allocated, that it needs to be 4 doubles wider, basically. So we're not actually performing any allocation on line 6. We're simply informing main that it needs to have enough, it needs to allocate enough memory for itself to hold this variable.
Is he basically just building a wall around some memory?
Well, yeah, it's
this is somewhere to put this amount of stuff.
Yes, and it's reserved. It's completely reserved. It increments the stack pointer X amount of bytes, where X is however many bytes the function needs. Is this how you can get a program to crash someone's computer? Just buffer overrun to heaps of larger and smaller indices? Yes. You can use buffer overruns to take over somebody's computer. Like I said before, they are the most common form of security vulnerability in any native application, and something you must be very vigilant about. I can't tell you how many days I have wasted on solving buffer overrun issues, where my code will be running great, and then under one circumstance, halfway randomly, for some reason, calling one particular method on one particular object fails because I buffer overran into the virtual function pointer table. And that happens, and it's very obnoxious. So be very, very vigilant about array indices.
Hey, Nelson?
Yes.
Is this probably a good point right here to go ahead and take a 10-minute break? We're at an hour and 5 minutes of recording.
Alrighty.
I mean, does that work for you?
Unacceptable.
Unacceptable? Well, let's keep going then.
No, it's good.
All right, guys, let's go ahead and take a 10-minute break, and then we will get back to it. And I'll go ahead and pause the video as well. And we're back. Welcome, Nelson.
Hi, Jason.
How you doing?
Radio buzz.
Let's continue with coding.
All right, so code is awesome, and we're going to learn about it. So continuing on the questions we've had about arrays coming in, there's quite a few. Should doubles be initialized every time? Not necessarily. I've covered that twice now, the situations that I would initialize an array. Is it possible to assign values to members of an array in declaration if the values are different, i.e. double stuff 4 equals 0, except not having all the values assigned to 0?
Yeah, right. Just initialization.
Certainly. We could say, in that case, yeah, we can do this if we wanted to. So as you see, I've specified all the members of the array. Okay. Sort of, kind of, almost. That's not a question. What data type is auto? We'll be getting into that. Sorry because before I got in, but if you write to undefined memory during one of our assignments, is there any sandbox protection with Visual Studio, or will this rewrite some random bit of data in some random file on our hard drive? Well, first of all, memory is not going to be your hard drive. Meaning your memory, writing to memory doesn't automatically necessarily go to your hard drive. I do want to back up one point because I know somebody's going to point this out to me. Yes, I do know about memory mapped files. But if you're not using memory mapped files, then you shouldn't have anything to worry about. Now, Windows by default has some protection built in for accessing other processes' memory. So it's very difficult to access other processes' memory from within your own process. So as a result, you should feel fairly safe about that. However, you will get a runtime exception, a runtime error rather, if you try to access memory that you are not allowed to access, which is most commonly what will happen with a buffer overrun. The worst buffer overruns are the silent ones that do rewrite a little bit of memory in your program that happens to be valid allocated memory for your program. But that's not going to cause any damage to your computer, but it will damage your program's integrity. Is an array just a pointer? I thought I read that somewhere. Yes, an array is actually just a pointer, but we are not talking about pointers yet. Can you just make an oversized array and fill unused portions with 0? Certainly. When you enter one number between the curlies, when you initialize it, it sets them all to that value, or does it just do it for the first item? It'll set all of the values to that one item.
It's like it's a shortcut instead of having to do 0, 0, 0, 0.
Right. Do we have to use main, or can we just leave it empty and do other functions? Well, you always have to use main. Main is your entry point into your program. However, that generally, almost always, you will be writing other functions in your program that will be invoked from main, but the only way that they're going to get executed is if you invoke them from within main, because main is your entry point. If you do not do something inside of main, that thing will not happen. So you need to invoke the code, the other bits of code, from within main itself, because main is the only entry point into your application.
I know it's not in C++, but the easiest example to see how this is often handled is if you open a new XNA game, because you don't automatically get shown it, you get to see the game class pop up by default. But there is a program class in that with a main that literally just runs the game. It creates a new game and runs it. That's all it does.
Yep, and typically that's how you'll write your C++ programs too. Your main method or your main function will most of the time, almost all the time, simply delegate to some other system in your code, and that's all it will do. And your actual logic of your program will be strewn about your project. How can you prevent another program from accessing data your program through buffer overflows? Well, you can, because there is a lot of protection in Windows for preventing other programs from editing memory inside of other processes. However, when I'm talking about the buffer overrun exploit, what I'm referring to is, okay, imagine if, this is the example I've been using like 5 times now, but I'm going to say it again. Imagine Photoshop, and you've discovered that there is a buffer overrun when Photoshop loads a PSD file. And you know exactly what byte that gets overflowed and by how much. And you run Photoshop through a debugger. You find out how many bytes forward you have to edit in order to gain access or gain control over the program. Then you send that you craft a PSD that causes that buffer to overrun in a very specific way so that your code gets loaded into memory. And you would then take the rest of your code, your malicious code, payload, and you'd stuff it into that PSD as well. Then you would have somebody else open up that PSD file on their computer, and then you would have successfully exploited a buffer overrun on another person's computer. Because the PSD is being loaded within Photoshop's process, there's nothing stopping it from overflowing into its own data. There might be protection for cross-process access, but there's not going to be protection from inter-process access. What is the name of the iReceive channel for the class? It is #class, but we are in BuzzNet. So be sure to head over to this web address and log in with your 3dbuzz username and password, and you will have access to the chat. So creating the array double product prices 4 equals 0 is or is not actually allocating memory for that array. Well, it is and it isn't, which is my favorite answer to any question. It isn't on line 6. In fact, if I were to remove this initialization, line 6 does not represent a single bit of executable code. Nothing happens on line 6. What we've done is we've told C++ that we want an array of 4 items long, typed to double, made available to us in memory when the main function starts. So we haven't actually done anything at runtime. This has no runtime executable code. Instead, what we've done is we've instructed C++ to make sure that when main is invoked, that enough memory is allocated for main to contain this data. So this does not represent executable code. In itself, it is not allocating a single thing. This memory, though, by defining it here, we are informing C++ that we want main to have enough memory to store that data for us.
It's basically like telling it to get ready. Yes? Yeah.
Yeah, it says
at some point we are going to want this much space.
Yeah, and every single variable you add inside of main will increase the amount of data that's allocated for that stack frame. But potentially, there are a lot of different rules in regards to how stack frames are allocated. So I guess a better way to say it would be by declaring a variable inside of main, you ensure that when the stack frame is allocated for main, that it has enough memory to store that data.
Cool.
Okay, so...
What is a char? Is I think where we're down to.
We're going to talk about different types soon here after arrays. I really want to get arrays down because arrays and looping are going to have the most questions, as we've seen, and I really want people to understand arrays and looping, even if they don't get to understanding the other concepts we have today, because they're the most important things. Unless I'm jumping in array, how do you initialize different types? Ooh, that's a good question. Something I haven't really specified yet. Arrays must be the same type for all items. An array has a type, and that type is the same for every single item within the array. I cannot make an array that has one double item, one int item, and one float item. That's impossible. And if you want to know why, it's really simple to explain why this is. Otherwise, if we had a double here, let's say we had a double here, but in the middle of the array, let's say we have a float. So here's how it's laid out in memory. We have 8 bytes, 4 bytes, 8 bytes, and 8 bytes. Now, all the math that's going to be used to index an item out of an array is broke. Because if I try to access item 2, if I multiply 2 by double, which is 16, that means I'm going to advance my pointer 16 bytes forward, which is no longer going to line up with the proper item. So this is impossible. Sort of kind of almost was in response to whether or not we all understood we were teaching about memory. I sort of kind of almost understand it. If you have any specific questions, feel free to ask. How do you make a dynamic array? Ignore if covering this later. We're not going to be covering this in this class. We are going to be covering this in, and by the way, everybody in BuzzNet, I'm actually writing kind of to the side because I don't want to put my tablet in front of my keyboard. So it is kind of, not only is it horribly sloppy, but it's also
back on topic.
I love that little slant. It's kind of funny looking. See, normally it's like this, just as sloppy.
Nelson.
Great. Anyway, so as far as a dynamic array, in C++, there's no such thing really. There's nothing like a dynamic array, because an array is this. However, there are ways to represent a thing that behaves like an array, but lets you add and remove items dynamically. But those things are called different things. And one of those things are called vectors. And a vector is an object that allows us to do that. We aren't going to be covering vectors in this class, but we will get to them in the course. There are also linked lists as well. Those are another, C++ has an implementation for a linked list that we can use to dynamically add and remove items from an array-like structure. Now, I'm being really careful to say array-like, because the distinction from an array and an object is very important. Do we have to use if statements for each product? Nope. I just kept this here so we can talk about indexing, but in a second I'm going to go ahead and turn this into a loop as well. In my high school C++ class 200 years ago, oh, C++ is that old? My instructor taught us to use void main rather than main, which is correct. Int main is correct. Void main is not standard C++. It might work with your compiler, but it is wrong. Int main and return 0 is very important, and it is the standard compliance, or standard compliant way. Java does have a void main, just like C#, although they don't have to be. Can you initialize a variable outside of main for global variables? You can, but I'm intentionally not going to demonstrate that because I discourage the use of doing that. And once we get into functions, we'll talk a lot about how we can pass data around properly without dealing with ugliness of globals. Nelson, array can store more than one type inside, like double or float or integer together? No.
You covered that.
I must have been a question before I did cover that, but the answer is no. An array must contain the same type. Is a for loop best for arrays? Typically, I will use for loops for arrays, but we are covering for loops next week. Alrighty. So, are there any more questions about arrays and looping? What I'm going to do is I'm going to go ahead and refactor this code down here to be a little bit more robust. Instead of statically referencing each one of the product prices, I'm going to use a loop to do that for me. So I'm going to say max price equals 0. I'm going to say product number equals 0. I'm reinitializing the product number variable. Then I'm going to say while product number is smaller than 4, if product prices at product number is greater than max price, then max price equals product prices at product number. So now we have our awesome program that does a lot of interesting things, including an infinite loop, which was actually a feature of the program. But instead, we're not going to do that anymore. And so now you see we get the proper result.
Now, just a point of order there. On line 18, you reinitialize product number to 0. You're reusing the counter.
Yep.
Rather than creating a separate counter.
Yep.
House style, best practice, or just whim?
Whim. Typically, because I would normally be using for loops, I usually wouldn't do this because, well, the for loop declares their own.
Yeah.
But I don't know. When I get in C++, I get so memory conscious. It's kind of funny. Like, I don't know. When I'm looking at C++ code, I always get the feeling that I have to reuse my data as much as possible.
Yeah.
When you just zero the variable instead of defining a new, do you use less memory? Yes. Because I'm no longer defining another variable, I'm using less memory. That being said, there's nothing stopping the optimization compiler to determine that it is possible for it to combine the two variables, and I'm sure that's an optimization that is performed by most compilers. However, I'm not 100% sure on that.
So do you mean if you declared product number 2 equals 0 on line 18, it could behind the scenes go, oh, hang on, this is the same as that, and I've finished with that, and I could use it again for this, or not? Have I misunderstood what you just said?
Yeah, I think that could be possible as an optimization. It would run into issues once you introduce pointers, but optimization compilers are generally smart enough to know if their optimization will cause a potential issue or not.
Cool.
Okay, so does everybody like my program? I thought it was pretty cool.
It's amazing.
Does anybody have any questions about my program?
It's cute.
It's cute.
Someone said it was cute, your program.
Huh.
O doubles doesn't run.
What's the error that you're getting, O double? Actually, everybody, go ahead and click on participate and type this out. I've been talking for too much.
Yay.
Bam, bam, bam.
And back to O double. What's the error? Nice, Don. Yes, I typed it out already. I typed it with Nelson in my mind.
In my mind.
Yeah, O double build errors. What's it saying? Built and compiled in your mind. Oh, that's fantastic. Oh, Nelson, remember this one? Look over in BuzzNet. System cannot find specified file.
System cannot find specified file.
We just saw that one last Monday.
Try restarting Visual Studio as an administrator.
I thought it ended up being something simpler than that.
I thought it was something that had to do with the file permissions.
I get the vibe that you beat your head against something that resolved into this for a few hours at some point.
Oh, wait a sec. Yeah, just hit yes.
That's it. And you click the thing, the hide button, or the never show me again, or.
Yeah, I click on the never show me again because I think that is the most inane dialog box I've ever seen from Microsoft, and that's saying quite a bit.
So for anyone else who might be having the same problem but watching the video, can you just give a quick rundown of what it is and why it's happening?
Generally, when you make modifications to your program and try to build, Visual Studio will ask you if you really want to build it, and you just have to say yes.
But this isn't, do you really want to build it?
Or is this a different one?
This is system cannot find specified file.
Well, I'm confused now. We can swap over to a screen, I guess, for a second.
We could.
So do you want... Oh, double. Swap over to your screen?
Go ahead, Nelson.
I can switch over. What's your real name? Or your name that appears in the BuzzNet or in the webinar? Am I just blind?
Easiest thing is O double. Type O double into the webinar questions panel.
Ah, that works. Unless you can't.
Your list needs to be sortable, Nelson.
No, this isn't mine. This is the webinar thing.
No, your other program.
Oh.
Oh, the anticipation.
Yeah. double, could you type something into the webinar chat?
Questions panel.
Questions panel. Yep, there we go. Oh, and of course... Oh, he has his hand up, too. Hello? So if you hit, or if you go to View up at the top, other windows, or sorry, not other windows, just error list. So if you double click on that, you didn't start with an empty project. So you can, just select all that text, hit Control X, and then start a new project. It's faster just to recreate a new project that is empty rather than undoing all the pre-compiled header options that it does.
And then we also have an actual syntax in there, but we can fix that after the new project thing.
Yeah, whenever you see anything like a pre-compiled header or stdafx, then you know that you need to start it with an empty project. It's actually, it's going to be that, and then whatever you want to do with that. And then, application settings.
Upper left. Down a little, almost. Yes.
and then just select empty project.
Perfect.
And finish. And now you're going to have to create a main file. So just right-click on your source files folder. Go to add CPP file, type in main, hit enter.
What?
Yeah, new item, then CPP file.
And then you want to type in main.cpp.
No, you need the C++ file, and then in the name checkbox you'll need to type main.cpp.
Okay, like, is this dumb?
No. Nelson does this every morning.
Then hit Control-V, and you should be good.
Except for there's look at, oh, we need to get some editor numbers up there, but we're missing a Terminator also, which now you can just double click on the error and you'll find the Terminator problem. And right above it, look at the line product number equals 0.
Yes.
All right. Awesome.
So now if you hit F5, you should get a running program. Or not. I think you're missing a curly.
Yep. No problem. Yeah, just hit no. That's okay.
And then look closely at your while loop. It looks like you're missing a nice little curly.
Help me.
Closing curly.
Nelson, go ahead and help them real quick with getting line numbers turned on for the editor. That'll make things a lot easier.
Yeah, if you want to get line numbers on so we can point out to you which lines we're talking about, go up to Tools, Options, Text Editor on the left, and then expand that tree. Go down to C++, and just click on that. Then go into General. And then
Down
display
under
line numbers is near the bottom.
Yeah.
Yep.
Sweet.
Okay.
All right, now.
All right.
Look at the while loop. Look, line 21, you have an opening curly brace. Where's its closing curly brace? The challenge. Wait. Curly brace is the wrong way now.
Curly braces always come in pairs.
Okay, so close the this.
All right, Nelson, see if you can kind of guide him into home. He's close.
See, your if is correct because your if has a opening curly brace and a closed curly brace, but your while. Look
Actually,
closely.
no, Nelson.
Oh, well, yes. You might want to actually. If I jump back to my screen, you could look at. You can look at the flow of logic and really think about curly braces as being associated with the construct above them. So notice here on lines 22 through 25, this is all encompassed by these curlies. These curlies define a block. And as a result, so you'll want to associate the block that contains the code that should execute given the if statement inside of the curlies, and then the code outside of the curlies will be not associated with the if statement, and then you'll want to be sure to end your loop right there. Does that make sense?
Oh, we can still hear you.
Yes. Yes, it does.
All right, sweet.
Okay, cool. So I guess just make sure you can get it jamming, and and let us know if you need help, though. Seriously.
Okay.
Okay, cool. Okay, so I'll go ahead and mute him. But seriously, if you need help, make sure you let us know. And back to you, Nelson.
Okay, so are there any questions about my while loop that I have here? Any more
Yes,
questions?
we just had a question come in on the question panel.
Is there any way to get 2010 Express to automatically make pairs of braces? Not that I know of. There is a tool called Visual Assist X, I believe it's called, which is a C++ add-in similar to ReSharper for C#. And it does support those features, but you're not going to be able to install it on the Express editions of Visual Studio. So the answer is no, to the best of my knowledge. But I don't use Express too often, to be honest. I only use it here for the classes.
The last two are both the same question, essentially.
Is it okay to have the contents of the second while loop in the first loop? Well, you can. This particular computation, you can combine these two loops. That being said, as a matter of style, although this code it is indeed more or less efficient than it could be if I combined the two loops together into one. But as a matter of sort of style, I really would prefer seeing something like this. If I was being performance conscious, however, I could combine the two. I could combine the two simply by taking the max price, bringing it up here, taking the if statement, and placing it inside of here. And now the program becomes smaller, but it does the same thing. However, the way I approached the problem, at least as far as what was I saying? Words. The way I approached the problem was I was thinking about mutating our data in two steps. Oftentimes, it's useful to think about getting your program to, or getting the data from the user into your program, performing actions on that data, and then printing the output to the user. Yes, there's more control this way than there is if I were to combine them. I have more flexibility, and it's cleaner to me. But then again, if I was being specifically performance conscious with this solution, I would indeed have combined the two loops.
But it's not, it wouldn't be very much more complicated in a program where you actually, the user could specify which prices to compare, in which case you would absolutely have to separate it out because you wouldn't want to do, well, you would.
Yeah, exactly. If we needed to do something that required the existence of all the products being added before we performed a computation, there would be no choice but to separate them out to two loops. Okay. Any more questions? So everybody understands loops. Everybody understands arrays.
While loops, anyway.
Well, while loops, sure.
Sweet, we have a class of expert programmers.
Ironsoul really wants to know what char is.
Are you ready to go and tell him?
Oh, somebody did ask a question. Do I need to declare product number on line 18? I'm sorry, Ironsoul.
That was great.
Okay. So on line 618, we're not declaring a variable, actually.
We're reusing.
We're reinitializing it to 0. If I did not have this, then the most expensive product costs $0. That doesn't make any sense. Well, actually it does, because product number is incremented to 4 to terminate this while loop. Because product number still contains the value 4 when we reach the second while loop, you'll notice in the debugger that product number is 4 right here. Because it's 4, the second while loop never executes. By reinitializing it to 0, however, you'll notice that right before this line of code, you'll see that product number is 4, but then after I reinitialize it to 0, it gets reset to 0, which allows the while loop to execute properly and perform our computation. Is it better style to initialize the variables on the top of your code? This is something I go back and forth on, but the simple fact is the methods or the functions and methods that I write typically are so small that actually in general a method or function should never be more than one screen line or one screen full at a time. So the practice of initializing all your variables at the top is silly, I think, when you're working with smaller methods that are or smaller functions or methods that are easy to comprehend on first glance. And like Atomizer points out, that was a requirement for C. It's also a requirement for a few other languages like Cold Fusion. But anyway, yes. I can't believe they invented that language. I can't believe it's, it still
Meanwhile, back in
exists.
C++.
It still exists. It still
I'm back,
exists.
Nelson. Let's wrap it back around.
Do we have to use block code for a single if statement? For right now, I would recommend that you do if you're new to programming. If you're comfortable with using this syntax right here, where we do not specify the curlies, you're more than welcome to do so. That being said, for a person new to programming, I highly discourage this. And the reason is you get into some very funky situations with nested ifs and elses that wouldn't make very much sense if you didn't have curly braces. Okay. How do we remove the override thing in Visual? I did something and now I can't type without deleting my code. It should be the insert key. I don't know why your insert key isn't working. I wonder if there's an option under Edit. Not that I see. Yeah, insert should go into overwrite mode, and then hitting insert again should go out of overwrite mode. Yeah, make sure that your key lock button isn't on either.
So does that pretty much wrap up those two subjects?
I think we're pretty much getting done with arrays now.
Cool. What's next?
Oh, someone just posted an esoteric programming language in BuzzNet. I love those so much. Okay, let's go ahead and talk about implicit typing. Ooh, is there any way to make IntelliSense pop up automatically like it does in C# for me? Not that I know of. A Visual Assist X does do that for you. And I believe that the next Visual Studio version does as well. But Visual Studio 2010, I'm not aware. Okay, let's talk about characters, actually. Thanks for reminding me. So we have a variety of data types that we can use in our program. We have the int type that we've been talking about, which stores positive and negative whole numbers. We have the floating point type, which stores a single or single precision floating point numbers. We have double, which store double precision floating numbers. We have a few other interesting things we can do. We can also store characters. Now, characters are a very interesting thing in C++. And they're interesting because they're really nothing more than a single byte. That's it. They're basically a single byte that we can stuff with numbers. In fact, we can do that. We can say char mychar equals, how about 49? We can stick any value in a character between the values of, well, it depends on if it's signed or unsigned, of course, but I'll get into it in a moment here. But typically, the upper bounds are either going to be, actually, I can talk about getting the upper bounds right now. So you'll notice here that I've been talking about how many values a particular data type can hold. There are limits to how many values something can hold. Computers are not infinite machines. Therefore, you cannot represent uniquely every single number that you could possibly create. You can create numbers that will inevitably be so large that your computer cannot uniquely identify or distinguish it from other numbers. So every single data type has limits. Let's talk about those limits. I'm going to include a header called limits. And then what we can do with this header is it includes the functionality for grabbing our the limits of our individual data types for our particular compiler and our particular platform. I can do that by using the numeric limits type and providing a parameter for whatever type we want to find the numeric limits for. So if I wanted to see the max value of integer, I could. If I wanted to see the min value of integer, I could as well. So now if I hit F5,
it'll flash by.
Now if I hit F5, you'll see the upper and lower limits of the int data type. So let's talk about char. Ten, 9, 8, 7, 6, 5, 4, 3, 2, 1. Wow. Nobody asked how I did the block selection this time.
I know, it's impressive.
Okay, so let's talk about characters. Characters are going to have a different min and max value as integers. So now if I go ahead and hit F5, you'll notice that the, oh, well, that's just silly. So now you'll notice that the upper limit of an assigned character is 127. The lower limit of assigned characters is negative 128. So basically, both of these values, integers and characters, both store numeric types, numeric information. But the difference is an integer stores at least 4 bytes of information given these constraints that are constrained by the C++ specification, and a byte can store this range of values. Now, why is it called a character? And what other behavior does the C# or C++ program or programming language perform on variables of this type? Now remember that types are not only just a count of bytes. That's one of the things that a type has. A basic primitive type will have a particular amount of bytes that it consumes for a particular compiler. So int is going to be 4 bytes, char is going to be 1 byte, and so on, at least on this compiler. However, they also have special behaviors when put in other contexts that differ between types. So, for example, if I say char ch equals 49, and I say int my number equals 49, and then I print both of these values, you'll notice what I get is very different, or very odd. And I love using 49 as an example. You'll notice that I get 1, 49, which doesn't make a whole lot of sense if you don't quite understand the way that cout treats characters differently from integers. Now, although we can store numeric values in characters, when they get used in methods like, or in objects like cout, what happens is they get displayed as characters. And the encoding that we are using right now is ASCII. We are not using Unicode, unfortunately. Unicode in C++ is a pain, but it's possible, and we will be going over it at some point. But for now, we're going to be using ASCII. ASCII, or the American Standard Code for Information Interchange, is basically a standard that associates a particular code point to a particular character. So you'll notice that in this decimal column here, we have a variety of different numbers that are associated with the corresponding characters in the ASCII encoding. So for example, the decimal 49 turns into the 1 character, which is the behavior, which explains the behavior that we got right here, where instead of printing out 49, we got 1 printed out. So I don't want to spend too much time talking about encoding, but I do want to point this out. ASCII, because it's the American standard for information interchange, or at least it used to be the standard, it isn't anymore, it only supports the characters we use in English, which, well, I mean, there happens to be more languages than English on the planet, and we definitely want our programs to be able to support them. And many different languages use different glyphs, especially Asian languages, which use quite a few different glyphs for expressing certain things. So ASCII does not support these international characters, so I want to point that out. Unicode is another standard of character encoding, which is an umbrella over the UTF-8, UTF-16, UTF-32 encodings that C++ can sort of support, but requires a bit of extra work that we're not going to be getting into just yet. But I just wanted to quickly point out the difference between ASCII and Unicode. I do also want to point out that when Unicode was invented, because it was invented by Americans, if I'm not mistaken, all the ASCII characters that you see here are actually the same in the corresponding Unicode encoding. But that's how it's hard to differentiate between the two, other than, well, you can't express any other glyphs from other languages. Okay. What's the difference between dot and colon colon? Well, here we go. Dot accesses a member. Colon colon accesses a static member. There you go. We're going to be getting into object-oriented programming in this course. So we will explain the differences between those two symbols. Speaking of char, someone mentioned being able to use character pointers instead of strings.
What on earth is that?
Well, we can't do character pointers and strings in this week because we didn't do it for the Monday class, but we will be doing that next week. So, yes.
Cool.
The answer, he was correct. You can store strings in a character. Well, you can store strings wherever you want, really, but you can reference strings as a character pointer. That's the C standard way of doing it. C++ introduces a type called string, which basically effectively wraps a character pointer at the low level, but is generally the preferred way to deal with strings in C++.
But we'll be dealing with that down the road.
Yes. Cool. Can I store a letter into a character? Yes. In C++, the character literal syntax is a single quote followed by a single character followed by another single quote. I've seen people do this so often it's not even funny, and this is not what you want to do. As you can see, that doesn't actually print out anything that, or, well, wrong one. I confused myself. You'll notice that that doesn't print out anything that we want. So do not put spaces between the actual glyph that you want to print out. But yes, you can represent a character literal that simply gets translated into the corresponding ASCII code. Somebody asked why this won't error. This won't error because character codes are numerical types in C++. That's just like how we can use a char as if it was a single byte integer. we can store character literals in integers. Now, remember how I keep on saying this. I'm going to say it again. C++ is very incredibly, stupidly liberal with data types, and it lets you get away with things that don't make conceptual sense and will confuse other developers and yourself if you decide to take advantage of this behavior in your program. I've seen people use things like the fact that characters can only store the values between 1 and 128 to write loops that only loop 128 times. And just stuff like that, storing character literals in integers, using
1-800 code well.
Yeah, all that sort of stuff you don't really want to do. What will my number print? My number will print something. 97, because that's the correct character code. Shouldn't it error if I do this? You know, I think it would, but it doesn't. Yeah, I don't know. Yeah, I seriously don't have an answer to that question. That's just how they made it. Alrighty, so it's about time to let Nelson step outside.
Yeah, sounds good to me. We can go ahead and pause here, take a 10-minute break.
Alrighty, well, I'll be right back.
Pausing. We're now resuming. You're live, Nelson. Did I not give you that smooth welcome back? Let's continue.
Yes, that was
with the smooth voice of smooth butter.
Anyway, so do we have any questions?
You're now going to have to kick yourself. You know that, don't you?
Who, me?
No, Nelson.
Oh, what do you do?
Political commentary.
Oh, yeah, good point.
Okay, so...
Autos.
Well, hold on, I need to parse through...
Go, questions. Questions, yes.
A string is not a primitive data type in C++, is it? It is not a primitive C++ type. Okay. Okay, so I guess we're going to talk about autos. Alrighty. For autos, I want to talk about signed and unsigned. Actually, because we can do that with the current setup that we have right here.
Absolutely.
Okay, so I have been saying the words signed and unsigned for a while now. And what I mean by that is quite literally, does a number have a sign? Does it have a positive or negative sign? Is basically what I'm saying. And in C++ and a variety of statically typed languages, we have signed and unsigned. Now, providing the signed modifier in this case actually does absolutely nothing because integer by default is a signed data type. Unsigned, however, means that every number that the value that can be represented inside of this variable, there's a B, I hate B's, can only be positive, so they can't be negative. And what that means, though, is that a signed variable has a bit reserved for determining its signedness. So one of the bits inside of memory is being used to determine if it has a particular sign, which means that that it can store fewer values. So an unsigned variable can store more values than a signed variable.
No, Atomizer, you're right. Nelson, you got far away. Stop petting the dog and concentrate on the class.
No, I moved my neck up to watch the bee that's getting closer to me.
You got a bee in your room?
Down. I opened my window, and now there's a bee.
Yeah, your audio got very low for a second.
Okay, so basically, we can go ahead and calculate those differences. So here's our int min and max. Let's talk about the unsigned int and max. And remember, this is a signed int.
Can you just use uint and so forth in C++?
You can type def a uint, but we haven't talked about type defs yet. So here we have it. Wow, that was horrible formatting. I'm embarrassed. Okay, so we have our signed int, which has this legal upper bound and this legal lower bound. Then we have an unsigned int, which you'll notice is twice as much, but in the positive direction for our unsigned int. So you'll notice its upper bound is this number, whereas its lower bound is 0. So then look at our sign char. Our sign char upper bound is 127. Our lower bound is -128. Our unsigned char is 255 as the upper bound and 0 as the lower bound. And then we have these two bits of garbage data being printed out.
And that's perfectly logical when you think about it, because they're the same size, an unsigned int and a signed int. So you've essentially taken the negative, all the space that you're using for the negatives, and piled it on top of the positives. You can see that particularly well with the char, because there's only 128 each way, including 0.
Yep. And no, I'm not hitting my keyboard.
Yes, you are.
No, I'm typing on my keyboard. I'm typing on the best keyboard.
And there was us just thinking you used the force.
Okay, so are there any questions about signed and unsigned? They work the same way with integers, floats, doubles, chars, and all that good stuff. Any questions? In what scenario would you use them? Well, you would use an unsigned integer if you wanted to, if you knew you didn't have to store negative numbers and you wanted the maximum amount of values represented. So it's if you want more values to be represented than a normal signed integer, then you can use an unsigned integer, but you just lose the ability to have negative numbers.
I'm so itching to give a MIDI example here, because it comes up all the time in MIDI. If you've got like a volume slider goes from 0 to 250, well, 0 to 127, whereas the pan, which pans left and right, the center's at 0 and goes to minus 63 and 64.
Yeah. So in one case you'd use unsigned, the other case you'd use signed.
Yep.
You want to use an unsigned int for your checking account. Do you not have any fractional dollars in your checking account? Because remember,
it would destroy his overdraft.
Yeah. Oh, dude, I would love to get overdrafted if I had an unsigned. That'd be nice. Okay.
Yeah.
So, okay, well, now let's quickly talk a little bit about Otto, I guess.
Who's Otto?
Otto is, it sounds like a really English name.
It's German.
Really? For some reason I think English, but then again, they're all in the same area, I guess. And yes, I did say that just to irritate you, Gavin. Okay, so Otto is not a data type, actually. Otto is what's called implicit typing. Didn't Otto used to mean something else in earlier versions of C++? You know, I could have sworn that there was an auto type in Technical Report 1, TR1, that was an automatic pointer. But I could be mistaken. And I believe, yeah, I don't know how the conflict resolution works in that case. But so the auto is called implicit typing. And what implicit typing means is that the type of your variable is going to be determined by whatever you initialize that variable to. So
just like var in C#.
Yeah, just like var in C#. So when I initialize my auto variable to 10, because 10 is an integer literal, you'll notice my number becomes initialized to as an integer. Now this is a C++ 11 feature, so not everybody's compiler is going to support it quite yet.
I think that's because, I was surprised you didn't mention that on the question. Didn't auto used to mean something else? Because I'm sure that came up on the previous lesson.
No, I did kind of answer it. I'm vaguely familiar with a class called auto from TR1 that was an automatic pointer.
TR1?
Technical Report 1 is a set of libraries that were developed as an extension to the standard of C++, and a lot of their libraries got incorporated into C++ 11.
Right.
Kind of like Boost. Okay. So yeah, there's really nothing more complicated about auto. However, remember, if you do not provide an initializer, there's no way for auto to determine the type that it's supposed to be. As a result, you get a compilation error. So any questions about auto? I do want to point out, however, auto, I was going somewhere with this.
Does it differ from var in any way in its behavior?
Oh, no, it doesn't. But you made me remember what I was going to talk about. Auto is not dynamic typing. I want to point that out. Dynamic typing is the ability to have a variable that can change types during the execution of your program. It's a common feature of dynamic programming languages such as Ruby, Python, PHP, and in some regards C#. Auto is not dynamic typing. Auto is implicit typing, meaning there is no performance overhead or degradation, or in any way are you going to cause yourself issues by using auto. Somebody just asked, auto seems to be more, or why not just use auto for everything?
This is my favorite because I like this. Basically, if you are capable of looking at a line of code and working out what auto represents, then the compiler is.
Right.
C++, that is. You can look at the line 7 there, and look, my number equals 10. 10 is an integer. Therefore, auto represents an integer. My number is an integer. If, however, you couldn't tell what was, if you had some, I can't think of an example offhand, but if you had something that you weren't sure of the type on the right-hand side of that equals, you wouldn't know what my number was, and neither will the compiler. Is that right?
Yeah.
You've gone ominously silent.
I noticed the dog was munching on something. I'm not sure what it is. Okay. Basically, so to answer the question, why wouldn't you use auto for everything? Well, I'm going to be honest. I use implicit typing exclusively in C#. And C# is the language that I spend most of my time in. And as a result, I got very, very, very comfortable using implicit typing in that language. And I would recommend that anybody who uses that language should use implicit typing. In C++, auto, since I've done a significant amounts of work in C++, that was prior to C++ 11 being standardized, so I never got in the habit of using auto for things. That being said, I don't see any reason compared to the reasons that I would tell you to use auto or var in C#. I don't see as any of those reasons being invalid for C++, and as a result, yeah, use them as much as you want. Okay. What situations would use auto for? Storing input you receive from the user? Well, that's a good question. You can't store. You can't. The type of auto cannot be determined at runtime. So you cannot determine the type from something at runtime based off user input. So there's no way to do what you described. A question is, auto my float, will this be a float? And the answer is no. This is a double literal in C++. So this becomes a double. If you wanted this to be a float literal, simply add the F suffix and it becomes a float.
Is there a D suffix? I know it's redundant, but does it exist?
No. It does in C Sharp, though. Okay. Is auto more flexible in terms of being transformed to another type and thus more easy to break? No.
That would be dynamic typing.
Yeah, that is dynamic typing. Auto is a compile time
Constant.
construct.
Ah.
And it has no bearing on what happens during the runtime of your application. Okay. Do you need to initialize, or can it even be transferable between other types? No, it can't. There is no difference between me typing in auto my number equals 10 and me typing in int my number equals 10. None at all. So this behaves just like any integer that you might define. Do you need to initialize auto? Yes, you must always initialize a variable that you are using implicit typing with. What happens if you create an auto variable and didn't initialize it to anything? You would get a compiler error.
This is what I was saying just now. You yourself would have no way of telling what my number is from that. And the compiler can't tell either.
What would happen if you create an auto variable and didn't initialize? Without getting way too far ahead, can you create a macro to convert auto to the appropriate types? I don't know. Depends on the extent of the macro automation library within Visual C++. I'm not sure if it provides you the compiler information to change it for you. I mean, later in the program. I'm still not sure what you mean. I mean, okay, well, let's say I have this. Let's say I have auto my number equals 10, and then auto my number 2 equals my number plus 3. Now, my number 2 is an integer now, but if I were to change my number to a character, you'll notice the type of my number becomes or remains an integer because apparently a character plus 3 is an integer for whatever stupid reason. But if I cast this into a character, you'll notice that I finally get continuously the incorrect results. It's hell-bent on making that an integer, isn't it? It really is.
It's got to be something on the plus. There's got to be something to do with the plus operator.
Yeah, possible overflow, so it's automatically up converting. So now my number is a char, but if I was to change the first my number into an integer, my number 2 becomes a character, or becomes an integer, sorry. Don't float have F after the number, otherwise it's a double. Yes. To be a float, you must have an F at the end of your F suffix at the end of the number, otherwise it's double.
I point this up just so that you can probably argue against it. From Buzznet Elevating said, shows us using auto may not be good to use always.
It depends. It depends if you really want... Okay, I want to point out that auto for primitive types might seem a little bit silly and pointless and stupid. But once we get into object orientation, implicit typing becomes very important. Because when we get into object orientation, we reach a point where we will be typically hard coding really long class reference or class names into our local variables. And in addition, if we were to change the types of a class that's returned by a function, those pieces of code would break. I know that was probably
one of the worst.
What do you think? Top 5 or top 10 horribly constructed
sentences? I was going to say one of the worst sentences I've heard you say yet. But I'll take that top 5.
Craftsman just threw a great example into BuzzNet.
Yeah, the dictionary, which in C++ would be map equivalent. So once we get into object orientation, it becomes a lot more important. Because conceptually, and this is what I say in C++ or C#, conceptually, the types of your objects, if you are using objects and not primitives, the types of your objects shouldn't mean as much as the names of the functions and the names of the variables that you're expressing. So it becomes more important to use automatic or implicit typing when we're working with larger or different types.
Show them one of those horrible, long, double colon filled type names.
Yeah, like, let's say we have a map of unsigned integers with values of a vector of maps of characters and vectors of ints. How many? Is that it? There we go. So now if we wanted to iterate over all of these values, we would have to use an iterator, which would require us to say iterator equals a.begin. This is how we would loop over this collection. But instead, we can use auto equals iter.a.begin. That becomes a lot more convenient when working with large or complex objects. The point for this isn't to be understandable. The point is that seeing that sometimes you do have classes or code that looks like this that can be greatly simplified with implicit typing. And most importantly, if I were to change this from an unsigned int to an int, I no longer need to change the type of my iter variable because it's being automatically inferred. So it makes the code more future-proof.
It actually makes you less likely to get silly little bugs in your code. Like when Nelson was sat there at the end there trying to work out how many closing angle brackets to use. it does that for you.
The point for this isn't to be understandable. Nelson, 2012. Okay, so are there any more questions about implicit typing?
How do you convert between types?
How do you convert between types? In C++, it doesn't matter.
You're not bitter about this at all.
How do you convert between primitives in C++? Well, you throw it, you just do it. Look, I just converted a character into a Boolean. So conversion between types, it is an important concept to keep in mind, though. Because C++ is such a liberal language when it comes to types, converting between types will cause you to lose information if you're not vigilant about where your conversions are happening. So, for example, I could have a double. My double equals. What did I just do that for? And if I were to print this out, I'm still not going to get that level of precision. Yeah, that's. Oh, come on, stop presenting that in exponent notation. I still don't like that level of precision. Anyway, so if we were to assign this value to a float, come on. Oh, I have a typo. Show me a better example. Come on, C++.
Oh, yeah, Wick, I think might have spotted it in BuzzNet. See out, set precision.
Oh, right.
Oh, do you want to explain that as well?
Once I figure out which header this comes from. I always forget the name of this one. I do pretty good with remembering the headers of C++, but I always forget the IO man IP.
I think you'll find it's probably for manipulation.
So you'll notice that the float has a less precision than the double. It's not capable of storing that much information. What we have here is narrowing, where although this is legal, here, there's the example I was looking for. Let's make this a little bit more interesting. End-L, actually, new lines will work across operating systems as well. New line characters are converted by the standard C++ output code thingies. The only difference between end-L and /n is that end-L will flush a buffer, which means that it actually technically could be slower in some cases, especially when doing file I/O. But anyway, so you'll notice that yes, we have more precision in our double than we do the float. This is like what C++ does. It allows us to do these sort of things without telling us about it, except in the form of little warnings we'll get. So notice that we get... You what?
Sorry, there's a real oddity with what it displays as well. Because why are the last two digits of the float 75?
Rounding.
No. It would round to 4243. 234243.
Well, this is just an example of stuffing that number into a float.
And as Atomizer just said, because he's absolutely correct, that's just floating point error.
Right. That's the kind of problems you get when you convert doubles into floats, when you perform narrowing.
Wow, I totally don't understand why that's happening. But carry on.
And so the only thing you're going to get from the C++ compiler is a nice little harmless, it's like Fluttershy speaking right here. Initializing conversion double to float, possible loss of data. So it's not in your face at all, and it's easy to kind of miss, but it is there. It is informing us that we are narrowing our double into a float. And that's going to cause us lots of pain and misery, like what I just demonstrated. So floats are, So basically, as far as type conversions goes, there are a lot of automatic conversions in C++. You can pretty much convert anything to anything in C++.
It's almost like it's just saying, in what way would you like me to pass the collection of bits that are listed here? Do you want me to pretend they're an int? Do you want me to pretend they're a float? They could be a string. It could be a banana.
Yeah. And then, as you see, I just did even more narrowing when I truncated off the decimal places by storing my float into an int. Same thing, though. I get a compiler warning, but this is legal to do implicitly. So it's easy to get confused very quickly when you don't pay attention to the types you're working with. So is automatic conversions in C++ automatic? They are. As you see, they are automatic. I'm not having to do anything to convert these types between each other. Actually, I'm just going to assign all of these to my double, just to show this. every single one of these things came from the same value. They're just in different types.
When it stores that as a char, does it essentially do like a modulus style operation?
I have no idea. Hold on. Well, it's... Yeah, I'm not...
Do you see what I mean?
Yeah, I don't know why it's I. I'm sure there's math that you could perform that would show you why.
Never mind.
Okay, so how do people feel about automatic conversions and narrowing? Now, there aren't any examples. Yeah, terrified. There's not too much we can talk about typecasting right now. So, yes, because all these conversions are automatic. Iron Soul, what are your questions? Is narrowing also known as demoting? Not too sure. Never heard of demoting. So basically, automatic, yeah. It's basically best to just really keep in mind what your types are and how the types interact with each other. Because otherwise, you're going to get into some very difficult situations.
Did you explain yet what exactly you mean by primitive, by the way?
Yeah, well, I think in the Monday class, a primitive is basically any one of these basic data types.
But not strings.
But not strings, because those are objects. So, yeah. I mean, basically, we have primitive types, and generally, objects are composed of primitive types. In C#, the strings are going to be considered primitives. Can you describe narrowing one more time, please? Yeah, narrowing is what we're doing here by assigning a my float to my double. We're narrowing the range of valid values and truncating data. So it becomes very annoying.
It's like trying to get into the genes that you had when you were 18. you have to start chopping bits off to make them fit.
Yeah, and you lose information.
And you've already pointed out list initialization. I don't know if you made that clear earlier when you were doing the double, when you were talking about the array.
Yeah. Yeah, as far as, in this case, we do get the same sort of implicit conversion here, because although 4 isn't technically a double, it is an integer and can be easily converted into a double. However, they did actually introduce some interesting things in the C++ specification where they made it impossible to do certain things with list initialization that are painful. So, for example, even though I can assign a float value to an integer, I do get a warning, but I can do that. If I were to create an int array, and inside of it place float values or double values, it still lets me do it. So there must be an issue with the particular compiler that I'm using not being standards compliant.
Yeah, isn't 2010's not all the way. It's 2011 where we're going to get all the way.
So is it just concatenating those then?
You mean Truncating.
Not concatenating. That's what I
Truncating.
mean. Wow. So is it just truncating those then?
Yep. It's just going to truncate them in this specific compiler.
Yeah.
I'm really curious. I've never tried to divide by 0 in C++ before. Let's go on an adventure.
Boom.
You'd better get a runtime error. I'm going to slap somebody. Ooh, here. We get a compiler error. Wow.
Hurrah!
Wow.
That's just Visual Studio saying, look, are you really? I'm not even going to let you.
I'll let you stuff a float and an int. I'll let you stuff a double and a float. I'll let you stuff a character into a Boolean, but I'm not going to let you divide by 0.
That is because it is rule 1 of mathematics.
Of course, we could trick it.
In all seriousness, my old math teacher at school used to make us write that in capital letters on the cover of our exercise books. Thou shalt not divide by 0.
We do get a runtime error, though, if we trick the compiler into letting us do this. Okay, so does auto work for arrays? No, it does not. In typecasting, when you input stuff from somewhere and turn it into a variable type for storing it in a variable, like inputting the text 1 and casting it to an integer, when we talk more about strings, we'll talk about conversion between strings and other data types, but you cannot cast a string to a integer in C++. Can't do that in C# either, not in Java to my knowledge. You can in more dynamic languages, but the thing about C++ is you're actually going to have to run that string through a library that understands how to do that conversion for you. It's not going to be a cast or an automatic conversion. It's going to be an actual...
He was actually asking what type conversion is, though.
What type conversion is?
Yeah, typecasting, rather. It said it is typecasting.
Well, it isn't. Typecasting is a language feature. When you convert a string into an integer, you actually have to run it through a piece of code. That happens at runtime. That's not a language feature. So it's not technically casting. Hello?
Hey, how's it going?
Hey. Oh, C++ you can typecast. The benefit to typecasting with primitive types, I probably should have actually gone over this. So, for example, when I place a double into an integer, you notice we get a nice little compiler error. But when I do an explicit cast, you'll notice that compiler error goes away. This is a way of telling the C++ compiler that we really do want to perform this conversion and that nothing it says or does is going to stop us. So this is an example of a basic cast from a float to an int. You basically provide the type inside of parentheses. Casting also has context in object-oriented programming too, but we're going to get into that later. Yeah, the typecasting thing, it's not a huge topic. It's just, hey, look, you can do this to make the compiler errors go away, or compiler warnings go away.
So what's next?
Okay, so I guess we can briefly talk about C++ arithmetic operators.
Sure.
Hopefully, how about static cast, dynamic cast, and reinterpret cast? Those casts only work when using object-oriented programming. And there's also a const cast as well, const_cast, but we're not going to be talking about that until we get into object-oriented programming.
There was one more question that's come in.
What's the difference between int blah equals int blah and int blah 2 equals int blah? I'm I've seen both syntaxes, and I don't believe there is a significant difference. I don't believe there is any difference. Yeah. So hopefully that answers your question.
So can you miss the parentheses out altogether then?
Oh, no. That would be a nice little compiler error.
Weird.
Okay. So I hope everybody here is familiar with these operators. Is there anybody who is not familiar with what these symbols mean in the context of mathematics? So these are called binary operators in C++. And they're not called binary because of anything that has to do with ones or zeros or that particular base. It has to do with how many operands each one of these operators accept. So for example, we can say int ble equals 4 plus 4. The addition operator is a binary operator because it takes in two operands, one on the left and one on the right. In this case, the integer 4 and the integer 4, which results, of course, into the integer 8. These are all binary operators and work exactly like you would say. So that would be 16, that would be 0, and that would be 1.
Do you just want to point up integer division while you're at the...
Well, I mean, you can divide with integers, but you basically get the same truncation that you would expect from casting to an integer.
Yeah,
Okay.
I didn't know if you'd covered that yet.
No, I mean, so if I do 4 divided by 6, you'll notice that when I run this, it'll still be an integer value, simply just truncated to 0 instead of the proper decimal, which in the proper decimal value for this expression would, of course, be 0 again, because the precision thing. Am I just mad? Oh, right. Seriously, Nelson? What's going on here is that these are going to be... there are some weird behaviors as far as division goes and the types that you use. So you notice that when I did 4 divided by 6, what I wasn't quite getting or was forgetting is that there's a difference in behavior between C++ and C#. In C++, this is going to perform integer division. No matter where we store it, it's going to perform integer division because both of these values are integers. So it doesn't do any upcasting. Okay, so Modulus. So I figured everybody would be pretty much more or less comfortable with these guys. So let's talk about Modulus really quickly. Modulus is a operator that simply returns the remainder of a division operation. So for example, if I say int ble equals 10 modulus, I don't know, 12, we should get 2. Well, if I were to print it out, we would. Or 10, if I am thinking about this backwards, and I should be. But anyway, so the point is, so for example, if we were to take...
12 modulus 10.
Yeah, that's what I was thinking. I was like, what? See, my brain is starting to fade a little bit. So yeah, we see that we do get the 2 that I initially claimed would come out. So for example, you can do this to find out if any number is divisible with another number quite easily. So for example, we could test to see if a number is odd. So let's say a number equals that. And to determine if this number is even or odd, we can say is even equals a number. Well, let's turn this into a Boolean, of course. A number modulus 2 equals 0. And we should get 0 being printed out because that is not an even number. But if I were to change it to an even number by saying last number is an 8, you'll notice that we get the correct result.
And in actual fact, we all use modulus all the... someone just said this in BuzzNet. You know, telling time, we use modulus. 6 hours ahead of 8 p.m. is 2 a.m. We've actually used the modulus there when we pass midnight.
Yep. Okay, does anybody have any questions about arithmetic operators in C++? So does modulus return the remainder? Yes, modulus returns the remainder of a division operation.
So set up some sort of example for him, Nelson. Put a loop in place and just have it go through and show each of the numbers being even and odd.
All right.
Yeah.
Don't sound so sad. No, Fizzbuzz should be homework at some point.
Everyone knows about Fizzbuzz now.
Yeah, that's the problem.
It's actually problem number 1 on Project Euler, although they don't call it Fizzbuzz. It's the same problem. I didn't say it isn't useful anymore.
I bet it's still very useful. Everyone who knows how to program has probably already done it. This is a 101 class. There's not supposed to be anybody in here that's already programmed.
And in any case, if that's so, then it can be used as a shibboleth for some sort of secret society based on who knows how to program and not. See, every cloud has a silver lining.
Okay, so I basically wrote out a loop that loops from 0 to 99 and informs the user which numbers are even and which numbers are odd. Highly useful, interesting, awesome program I have here.
Well, don't hide
the
code. They might want to see your awesome, amazing program. Jeez, Nelson. Let me show you my awesome output.
Restricted code.
Yeah, exactly. Here's my awesome output code. You can't see that. That's out of the question.
Okay, does anybody have any questions about this code? Anything at all? Modulus, looping, cout, if statements, else statements, sin.get, return 0, int main, include iostream, using namespace.
I have a question about Streeter and what the rules of this drinking game are. But anyway.
Do a Fizzbuzz drinking game?
Apparently so.
I'm done with the drinking game. Programming drinking game.
We've got a question about, that's about string padding, so...
No, somebody asked, why is equivalent to 0 in the definition, or in the initializer? And, wow, I actually did it again as well. I aliased it out to a Boolean for some reason. Oh yeah, because I was going to use a ternary, then I realized that can't use ternaries yet. Okay, so what we have here is an expression, and index modulus 2 will return the integer value 1 if it is odd, 0 if it is even. Now, because this Boolean is named is even, I want to invert that. So I want to say if it's 0, say that it's even. Otherwise, if it's odd, say that it's not even. Now, I could have done that to invert it, but this leaves a bad taste in my mouth because I'm taking the result of an integer operation and performing an operation, a unary operation that should be only applied to Booleans. So instead I opted to go with equals 0, which not only turns this expression into a Boolean, because the result of an equals operation or an equivalency test is going to be a Boolean type, but it also inverts the result so that index modulus 2 becomes, when it's 0, that means it's even. So is even gets set to true.
Did you actually specifically mention about the double equals and how it differs from just an equals?
I think we did that in the first
For the Friday people? I've lost track of which one's which.
Yeah, that's like Don just said. We did that in week 1.
That's cool. Just checking.
Because we did if statements.
Okay.
Mac! Hang on, no, Mac is dedicated. It's 5 a.m. and he's enjoying a lovely sunrise. Continue, Nelson.
Is 0 even, or does the program just think it is? According to my program, it's even, so it's even. I don't know.
A number is even if it's divisible by itself in 2. So, yes, it must be, I suppose.
Well, it's not divisible by itself, because that's impossible.
Are they doing an open beta for Diablo 3 for everyone this weekend? If you haven't checked it out yet, Diablo 3 is
I don't see
awesome.
how that helps.
I'm not going to have time for Diablo this weekend.
Man, that beta was so awesome. Oh, man.
Is it time for a time check?
Yeah, we could take a break. I mean, it's close enough.
I'm not sure how far down the list of what to do you've got. I suppose we've still got homework and stuff.
Yes, we got homework and all. So, if you guys want to take a quick 10-minute break, we can come back and then wrap things up.
Well, we have const and size of, which will take in aggregate 5 minutes to explain.
You say that.
What?
I said you say that now. So yeah, have you?
Okay, break time.
Well, yeah, break time. See if.
And we have resumed.
So.
Yes.
Well, a few questions have come in.
What about memory or my program is giving the opposite and wrong output? Make sure that you're inverting the Boolean by asking if it's equivalent to 0. Do you need that bool on line 10? Can't we just pass that argument into the if condition? The answer is yes. Can do this. And that would actually be nice and preferable. I do like aliasing out Booleans. Well, first of all, because as I was typing this program, I was kind of in my mindless, code state where, you can sort of see everything that you need to write and your hands just, do whatever they do. And I was going for a ternary, and then I realized, wait a sec, we can't use those yet. This would be more correct. I also like aliasing out to Booleans because I really like driving home the fact that the equality operator is not constrained to be used inside of if or while loops. A lot of people think or see that it's kind of scary or think that they can't use equality or inequality operators outside of these constructs when in fact they can. So I just like driving that point home. But yes, this is equally valid and in fact more so.
Is there actually an equals method, EQALS method, like there is with your equality members in?
Remember that none of the all of these values are not objects. Int is not an object, meaning it has no members on it.
Oh, of course, yes, sorry. Duh.
Okay, so moving on to constants. What is a constant? Constant is a variable that never changes.
They call it a constant because calling it a variable would be very silly.
Yeah. There's your constant. You can declare it. You cannot assign to it. You can use it. Very straightforward. Size of. Size of gives you how many bytes a particular object or type will take on your particular platform and compiler. As you can see, the size of double is 8, meaning that double has 8 bytes allocated for it, whereas the size of float will only have 4 bytes allocated to it.
And an int?
And an int will only have 4 bytes allocated to it.
On your compiler and...
On my compiler and platform. So there's your size of, and there is your constant. And I think I got through that even faster than 5 minutes. Any questions?
All right, then has anyone not got questions?
Is anyone still awake?
Mac is... And Bando says brain divided by 0.
I'm going to convince my future children that there's gremlins how the computer crunches numbers.
It's a Discworld reference, gotta be. Should be if it isn't.
This lesson was a lot nicer than the C# lesson. Oh, just you wait. Once we get into object orientation in C++, you will beg me to switch over to C# in the middle of the lesson.
Yeah, I can't wait for C++.
To be honest, I was at that
102.
point about 2 hours ago.
So,
This
yeah.
does come back to the point of was somebody asked earlier, if you know C++, will C# be easy? And this is starting to show up why. So much of this stuff is done for you by .NET.
Right. Doesn't mean that C++ isn't a great language to learn or even use if you have good reasons to use it, which there are plenty. But, yeah, it is definitely...
But the thing is, it's a double-sided coin, because the other side of it is this really, if you understand C++, you actually do have an understanding of stack, garbage collection, all those things that, because they're done for you in C#, it's like it does it for you. And so if you just learn C#, you don't have to worry about all this stuff. Well, you should do, but it makes it... what am I trying to say? It's easy to program adequately in C# without worrying about all the stuff that you have to in C++.
All right, so you guys ready to go over all the homework stuff then? We won't keep everybody all strapped down just listening to us, jabber along for nothing on a Friday night. That'd be horrible.
I got ponies to watch.
Yeah, you got a pony marathon to go through tonight. I forgot about that.
Yeah.
He really does, Don.
To harass Segfault while he's doing Lud and Dare.
How many episodes are you planning to watch tonight, Nelson?
24 plus 3.
Yep, you have a real marathon planned. Wow.
Because the season finale is tomorrow.
Yeah, Bando, it's the new ponies, not old school ones.
Oh, that's scary.
Yeah, they are. That's funny.
See, now you see why my initial bemusement at why you got into it, because that's what I grew up with, the original one.
Pinky, please.
Anyhow. Homework.
Oh, no, Pinkie Pie. My bad. Hang on. And we've now resumed the video.
Okay. So homework. Let's talk about homework.
You get it easy on the second class. Actually,
Yeah,
you don't. Oh, yeah, you do.
Yeah, because you've already done this.
Yeah.
That's a lot of badges.
It's too many badges, but let's carry on.
Okay. So, homework. Project name must be homework 2. Oh, by the way, if you want to find out this homework, click on this at the end of the class. It'll be posted here. Or on the 2A class, it's going to be the same link. And then click on homework. Now, the homework, we want to ask the user how much money they have, present a list of products to the user. There must be at least 4 products listed, name and price. The user will select an item from the product list, or they indicate that they want to exit. The program will inform the user what item they purchased and how much money they have left. The program will continue to execute until the user doesn't have enough money to purchase anything or decides to exit. And we want to allow for pennies, cents, and etc., fractional currency. You are allowed to use while loops, if statements, sin, cout, arrays if you want, any primitive data type that does not include strings or vectors or maps, and of course variables. Because, I mean, We should take this out, Gavin, and see what they come up with.
No for loops. No for loops. That's right. Whiles. Just
No
because
for
that's
loops.
yeah.
Okay, so is everybody good on the homework? Forum site's gone down.
Really?
I don't know what you're talking about.
Yeah, it's working great for me over here.
Yeah, something weird just happened. I think perhaps everybody was probably spamming that thread at once.
It's working for me.
All of a sudden it froze up. It seems to be working again now, though.
Looking at memory usage on BuzzNet. Nothing.
Yeah, it's fine.
Okay. You guys are using a brand new BuzzNet, by the way. Okay. Continue. Yeah, it's running great.
So any questions?
Can we do whiles?
Well, yeah, I think I said no. Well, actually, no, I did show people do whiles today.
Ooh, if you showed it.
Yeah, so we'll have to include that. Then the Monday people will feel kind of upset, though. It was a question. Somebody specifically asked me if there was a way to get a while loop, but that always executes at least once.
Then don't be so, conflicted about it. Just say no. Or sit there and battle with yourself.
What was that Dare taught me? Say no again, cold shoulder.
Focus.
Power in numbers.
Focus.
Do we need to validate input? No, you do not need to validate input.
Good question.
Okay, sorry about that. I was just fixing up something that I spotted in the forums. Do you want to talk about the master submission steps thread? In fact, if you refresh that one you're looking at now, it should now have a link in it.
Okay, basically read this. I mean, I could read it out loud.
This is in the member sponsor lounge.
This is very important.
And yeah, this is just, it's all written down there. Just follow these steps and things will get set up. I've actually put it in there now. Submit a separate PM for each class you're attending, but also if, like this class, has 2 separate sessions each week, the homework's the same for each session, so you only need to send 1 PM, even though you need to register for the separate different class. Yeah, it's not instantaneous setting it up. There's a little bit of work we do behind the scenes, so I'm doing them in batches once a day. Other than that,
yeah, BuzzBJ
this seems to be going a lot more smoothly.
BuzzBJ at 3dbuzz.com. I'll love anyone who sets me as, the one who referred you to Dropbox. Ignore what Nelson's typing.
And I think the easiest way is probably just to click on acquire a Dropbox there in that thread. That will take you straight to Dropbox.
Oh, am I supposed to click on something?
No, I was just seeing as you two were pimping yours.
Yeah, but I have the power to do sweet things to people that are sweet to me. Oh.
Yes. To be fair, it wasn't my idea. That started out as Zach's referral. And I suddenly noticed it when I went in there to edit something else. I went, oh, that's a good idea, and changed it to mine.
All right.
When I get up to my 16. Anyway, sorry.
Anything else? Nelson, anything else over in the questions panel that needs to be addressed?
I'm looking, but I don't see anything.
Then I think that's pretty much it then. So a very easy second night, first night as a real class. We'll be kicking things off again in just a few days here. We'll be firing up week 3 on Monday. So you guys are always more than welcome to join us for both the Monday and Friday class. Please make it a habit to start jumping into BuzzNet. That's very important.
And congratulations on everyone just sticking with us, because we've still got most everyone that
which is very impressive on a Friday night. What is wrong with you guys?
It really is. Good guys. Well, see, that's why they want to be programmers, you see.
Oh, they're just getting used to it now.
And everyone suddenly goes, what? It's Friday?
Ashley skipped a birthday party for this? What? No, it's Friday night. That's impressive.
Oh, this class only happens the once. Birthdays are every year.
And for most people, yeah, it is tomorrow already with a lot of the crowd that we have in here. Well, let's not keep you guys held up any longer. There's still time left to enjoy the weekend. So go and do that. We'll be back on Monday for those of you that want to join us. Otherwise, we will, or at least Nelson, we'll see you next Friday. I will be somewhere up in the mountains, which will be awesome. So you guys have a wonderful weekend. Goodbye, everyone.
Goodbye.
Bye.